Get started right away. I have 15 minutes. That's not so bad. Okay, so up to this point we've been learning Algebra 1. Algebra 1 is awesome, awesome, awesome. Algebra 2 is awesome. You guys are really well prepared for Algebra 2. Geometry is sort of often, usually, stuck right in the middle between Algebra 1 and Algebra 2. And I never could figure out why. But it is. For most people, for most schools.
No one knows why.
I have heard, some people have said that they feel like for Algebra 2 you need a more mature mind in a way, and as you grow you get a little bit more, your mind is able to handle concepts better. I think there's some validity to that, but I think that geometry also needs that mature mind sometimes, and so I don't think it really matters which one you go to first. I would definitely recommend Algebra 2 next, but that's not how it is. Yes?
I would have Waldorf as Algebra 1 in 93. Because when I started it, Algebra 1 text.
A lot of schools do that.
Yeah. But a lot of schools do that. If you go to Santa Fe High, they highly recommend that you take Algebra 1 your freshman year, even if you've had it now. I would not agree with that. I would say unless the one thing about moving to algebra, if you decide to skip Algebra 1, you just have to realize you're on the calculus in high school track.
Yes.
You have to understand that, because if you don't take Algebra 1 freshman year, but you jump right to either Algebra 2 or geometry, then the next year it's either Algebra 2 or geometry, and then your 11th grade is going to be pre-calculus, and your 12th grade is going to be calculus. Some of you might not want to be taking calculus. You know what I mean? It's not going to serve everybody, but that's up to you, and it depends on the high school. I think to graduate from high school, technically, you only need to have completed Algebra 2.
What?
Algebra 1, Algebra 2, and geometry. But some high schools have a policy. I believe, Landon, I think your mom's Monte Del Sol, your mom's school, I think they have a policy that you have to take math for 4 years, all 4 years. So if you pass out of Algebra 1, you're going to have to take either calculus your senior year, or maybe they offer a statistics course or something else. I don't know. But so it depends on the high school you go to. So you just have to be aware. Some people prefer to take Algebra 1 again in 9th grade. Nothing wrong with that. There's so many new things you're going to be dealing with, new teachers, a new school, new friends, all sorts of things. So it sometimes is comforting. I think like Julian did that. It's comforting to go to, when you go to a new school, to take something that you're going to do well in, right? That there's not going to be a lot of huge surprises, right? And you can take Algebra 1 again and then master all those other things you're mastering, and then the next year you move forward, right? So however you want to do it is fine. But geometry is sort of this weird thing in the middle of it, right? And there's not a ton of algebra in it. There is some, but not a ton. And but what we're going to talk about today is parallel lines, transverse lines, and assuming I have time, triangles and angles. Some of you have probably been exposed to this. I think Matt has taught this stuff. You guys tell me if I'm wrong. But let's say you have a parallel line, two parallel lines.
That's not a line.
Okay, two parallel lines. How would I denote that those are parallel?
Because they are directly parallel to each other.
All right, but how would I denote? Like, I could make two lines look parallel, but they're not parallel because 3,000 miles away they actually cross, right? How do I denote on this that they're parallel, Elizabeth?
Well, I think there's some sort of graph you can do for them, and to see if they're actually completely parallel, if they're slightly slanting.
Okay.
I've had them where they slant slightly, but they look parallel.
Right. Okay, that's very, very correct. But I'm actually asking about what I'm asking for. Shh, guys.
Wait, with the
what I'm asking for
right now, or
what I'm asking for is what could I do to these two lines right now to tell everybody that these two lines are parallel? Okay, Alex.
see if they cross.
Okay, but yes, that's correct, except that I'm asking what notation could I put on these to show that they're parallel? Tess. Yes, there's different ways. Like a lot of times you'll see this. You'll see a little arrow like this that says that that means they're parallel. That means they're parallel. Another way you'll see it is like this. You'll see a little arrow in there. That tells me immediately those two lines are parallel. So I know that they will never cross. They will never intersect, right? Now, those are parallel lines. This is called a transverse line. So that is your transverse line. Transverse line. It transverses the parallel lines, okay? Now, let me just make this a little longer. Okay. And we're going to go A, B, C, D. And we're going to go E, F, G, H.
But you didn't do them the same way, though.
A and F are the same.
Oh, A, B, C, D. You're right. I didn't do that.
So it has to be E, F, G, H.
Alright, so I'll do it the same. Doesn't matter. But I'll do it the same.
A and D are the same.
E, F, G, H.
A
Okay,
and
A,
D
B, C, D,
are the same.
E, F, G,
A and
H.
H are the same. F and G are the same.
Alright?
Because
Yes.
they're
So,
directly across from each other.
what we have to do is we're looking at angles with these things. First of all, if this line and this line are parallel, would you agree with me that they create, with this transverse, the exact same angles?
Yes.
It makes sense, right? The only time these angles would be different is if one of the lines was not parallel, right? So this transverse is intersecting this line exactly the same way it's intersecting this line in terms of the angles that it's creating. Now there's certain parts that you need to, there's certain vocabulary that you're going to have to get to know. And anything between, any of the areas or angles between, well actually hang on, let's alternate this area. Yeah. Any of the space, any angles in the space between the two parallel lines are called interior angles, okay? They are interior angles. Okay? Anything that is outside, right? Outside of those two parallel lines are called exterior
Oh
angles.
wow, that is nice.
Right? Exterior angles. Okay, these are exterior angles. Okay, and the abbreviation for angles, by the way, is this. Okay?
It's like
So exterior angle. It's sort of like a less than sign, but it's the bottom part is flat, is horizontal. Does that make sense? Right? Okay, interior angles and exterior angles. Are C and D interior or exterior angles?
They are interior angles.
All right, are G and H interior or exterior angles?
Exterior.
Okay. Now, which angles? Oh, there's one other thing I want to talk about. Vertical angles. Does anybody know what a vertical angle is?
the one that like goes like from the top to the bottom.
Is it like this way?
If I did this, and I said this,
Vertica.
That's your vertical angle.
what if this were 25 degrees? What would this angle be?
25 degrees.
Are you sure?
Yeah.
Is she? Are they right, Elizabeth?
Well, if they're intersecting.
What would this angle be?
Yeah, if those lines are straight and they're intersecting and that's 25 degrees.
What?
What is that?
It's two lines crossed, two straight lines. So if this is 25 degrees, what would this be? 25 degrees.
Together.
That is called a vertical angle. Now, these two are also called vertical angles, even though they're not vertical, right? These are the vertical ones, right? But these are also called vertical angles. It doesn't matter which one's facing up and down. It just means the two angles opposite each other, when you have two lines intersecting, those are called vertical angles, right? So if this were, what would this angle be? I'm just curious. Does anybody know?
Whatever 180 minus 25.
Right, because this has to be 180 degrees, so 180 minus 25 would be 155.
Yeah.
165.
155?
55.
Okay. What did this be then?
Same thing.
155. Okay.
They make 300.
Now, all right, that's correct. Now let me ask you one other question.
360. Oh my gosh! You're making
I have-
360 like a circle.
I have put these two little arcs here, and that when I have one arc here and one arc here, just like that, it means those two angles are identical. Okay. Now, could I do this too? Would it be okay to do this?
Yes.
Well, no, you'd have to do 2 lines. You'd
Yeah,
do
that
double
tells
line.
me that all 4 of these are identical. That does not look right to me, right?
you have to
So
do
I
like
would
that.
have to do 2 circles, 2 little arcs. That tells me
And
that
so
these
on
2
and
are
so
identical
forth. It's like
and
handles.
these 2 are identical, right?
And so on and so forth. Like,
Okay. Now, can I erase this? So all we're doing is really just the foundation for geometry, for what we're going to be doing. So let's talk about the angles. We're going to say, okay guys, can we stop the singing right now? Let's list some vertical angles from here. Give me some vertical angles. Look at all these and all these. Tell me what are vertical. Clayton.
B and C.
B and C. Okay, what else?
A, D.
A and D. What
E
else?
and H. F and G.
E,
D, H,
E and
F, G.
H.
E and H.
F and G.
F and G.
F plus
A
G.
and
Okay.
H.
Here's the
What?
A and H.
A and H.
Wait, those are.
Well, those are technically not vertical angles, but they are equal.
Aren't A and E though?
They are equal. So we've got
and E.
what?
And aren't A and E vertical angles though?
No, vertical angles would be when you have 2 lines intersecting, they're completely opposite each other. It doesn't, what you're noticing is that the angles are the same. They're just not vertical angles, right? D and what? Well, those are not vertical angles because
like that.
they're
No,
the,
there has to be this one.
yeah, okay. So those are not vertical. Now, there's another thing called alternate. Now there's another thing. Make sure you write these down. These are names you have to know. Alternate interior angles. All right. Interior means between, inside, right? What angles are could be considered alternate interior? Try a guess. What would you think?
E, F, and C. Oh no, F and D.
What's
And E,
Alternate
F.
interiors would be D and F.
All right.
Yes.
Would you guys agree with me that if F were an interior angle,
It is.
an alternate interior
We see.
would mean you go across the transverse line and up.
So F
So
and C and
notice I'm going up here. F and C are equal.
What about
F
D
and C are alternate interior. Do you see why? F is here. You're going to go up here and then go across the line. You're alternating to the other side of the line. So F and C are alternate angles. So F and C. And then E and D. Those are the only 2 alternate interior angles. That's it. Okay? Now there's also things called alternate exterior angles.
I called it.
Okay? So who would like to guess? So Adam, can you guess? Or Wyatt? Can you guys guess an alternate exterior angle? Pair? Either one of you 2. B and G. Do you guys agree with him?
Yes.
Yes.
Yes! Totally. Excellent. B and G. What else? What's another one?
A plus A.
A and H, right?
And that is all.
So they're not. These are not that hard to do, right? Now there's another kind of angle. Running out of space.
Gary, do you want a few more minutes?
I'll go ask for 10 more minutes.
If I could have just a little more time, it would really help me. Like 3 more minutes. Ask him for 3 more minutes. You guys, quick! It's about to ring the bell.
Do that way, sorry.
Just see. All right.
More like
What if I say no? No more minutes.
Then I stop my lecture. Okay.
Is it recording? Gary, is it recording?
5? Oh, really? Awesome.
Gary, is it
Great.
recording?
All right, guys. Yes, it's still recording. All right. So another type of angle. So has everybody written these words down
Yes.
in their notes? Because it's really important you know these. Another one are called corresponding angles. Corresponding angles. Now, to explain corresponding angles, remember when I started this, I said, do you agree with me that since these two lines are parallel, that this little cross-section of angles is identical to this little cross-section of angles?
Yes.
You agree with me? They're exactly the same. If I cut this out and moved it up here, it would fit perfectly. You see what I'm saying? Therefore, corresponding angles are angles that have the same corresponding location. Like, what would, like, say, okay, G and what?
C.
G and C. That would be a corresponding
B and
angle.
A. B
G
and
and C. What else?
B and F.
What? Wait, one at a time. What?
E and A.
E and A. That's correct. To the left of the transverse line and above. To the left of the transverse line and above.
F and B.
So A and E and A. And what?
F and B.
And H and D.
F and B. And what? H and
D.
H and D. Notice there's more of those, right? Than for some of those. Okay. Awesome. So does that make sense so far?
Yep.
All right. Can I erase this?
Yeah.
A, B, C, D, E, F, G, H, L, M, N, O, P,
Okay. I'm going to erase this now. I have, okay.
I used to think elemental was one letter.
Elemento.
I know, me too.
How would you put that in like a word?
Elemento.
Elemento.
Elmo.
Sometimes I.
L-M-N-O? It's not
Elmo. Elmo. Elmo.
What about the N?
Elmo.
N comes after M.
Elmo.
L-M-N-O-G.
It's Elmo.
All right.
E-Z W A
I like this shape.
2 3
Parallelogram.
All right. What do you know about this shape right
It's
now?
not parallel.
It is not parallel. The two
Oh,
lines are parallel.
they are.
They're parallel, like parallel.
These two are parallel. These two are parallel, right? Right? You know that.
Parallelity.
It's the dance.
Hang on one second. Let's see. X.
Dance. Gary, you invented the new dance.
Wait. Sure, that's okay. And then Y. All right. Okay. Find the unknowns. Find the X and find Y. So raise your hand if you have an idea.
Well, Gary.
Oh, I know.
He has two ideas.
Wait. So utilizing this information that we just learned, that's what I'm wanting you to share with me. Okay. So Karen.
So would Y then be 30 degrees?
Y would be what?
30 degrees.
Y would be 30 degrees. Why?
Because they're transverse.
So
Because they're parallel.
Well,
what is that called? What kind of angle would that be called? Y and 30. What are those?
Alternate interior.
Alternate interior angles, right?
Yep.
So they have to be the same. So Y is definitely 30 degrees because you have parallel line and you have a transverse line. Just doesn't look like a transverse line. If you make it go longer, you suddenly realize it is a transverse line. Does that everybody see that? All right. What about X?
70 degrees.
Celsius.
Now, how come? Why?
Because
Same thing.
Why?
Because.
How do you get alternate interior?
It's.
Oh no.
They're just interior angles.
Well, this one takes a little more thought, right? Think about it. If this were, you know, parallel lines, right? Which they are, actually, not yet, but they are, right? And that's my transverse line. Look at this. This is the same as this. Do you agree with me? Right? And this, that means X is the above the line and to the right. That means this is X as well. You see that? See what I'm saying?
Yes, yes.
That would be an alternate, I mean, that would be a, well,
Wait, now.
So, like, Gary, like on the test, if you want us to draw out those lines, the dotted lines.
so that would be technically like a corresponding angle. Do you see what I'm saying? We're above the line and to the right. Above the line and to the right. And we know that this, because this is called a what? Vertical angle. We know that X is 70, therefore X is 70. So X has to be 70.
X next to the lower X. Like, there's
Right.
there's another X.
What? Say it
There's
again?
another X over there.
And there's another X here, right? Exactly.
Wait, no, there's 70 there.
Right.
70 is X.
Right. 70 is X.
But if
Right.
70 is X, it doesn't matter.
Okay. Now, I think most of these you'll be able to do. There's one other thing I want to cover really fast. What are the different kinds of triangles?
Isosceles, the parallel, and then
Isosceles, parallel, and right.
the right one.
Isosceles, parallel, and
And
right.
flex
Isosceles,
square.
scaling,
What about the left
The right
triangle?
angle. It's a right angle. Right, isosceles, right, and equilateral.
Well, isosceles.
Equilateral.
Trigonum.
Straight.
Sided.
All right, really fast. Let me just show you one thing. For an isosceles triangle, if I have an isosceles triangle and I say this, what does that mean?
That those two sides are the same length.
The sides are exactly the same length. Okay, just hang on for 1 second. The sides are exactly the same length. There is a rule. I'm just sorry. I didn't have enough time to do this. But there is a rule that says if sides of if two sides of a triangle are equal, then the angles opposite those sides are also equal. Okay? So if these two sides are equal, these two angles are also equal. Okay? So I know that's an X and that's an X. All right, that's it. So homework right now is this. This is to play with. I want you to just do your best and try to identify.
Oh my god. Can I get one to start it? Wait, Gary.
Why does it smell like vanilla in here?
Having a big
I got one right now.
Are we still recording? It is. Hello, viewers at home. Wait.
Who's missing today?
All the people on the board. It's an angry triangle.